I'm going to do a longer answer question for you today. This one is from Unit 1. It's to do with electric circuits, but it also includes some graph skills. And I'll just show you how you can get the most out of these particular marks. So here we've got a little bit of information on the experiment that's been done, and you can see that someone has already plotted some data on a graph for us down at the bottom of the page here. What the exam board want you to do is to take this set of data here, which is for a resistor, and they want you to plot this onto the graph below. So I'll just whiz through that now. So we've got voltage on the bottom. It's nice, this one. They've drawn the axes for us. They've scaled it nicely, relatively convenient units. So you just need to plot out those points. So you're just going to go across and you're going to go up until you reach the required height and plot all of those points from up here onto the graph. I've just sped that process up. And it also wants us to draw a suitable line. So we're just going to grab a ruler because they look pretty straight to me. It looks like it's going to go through all of those points very nicely and through 0, 0 over here. So ruler on, draw straight through. Okay, no nasty curve to deal with today. Now the next question is nothing to do with what we've just done, but needs us to use this here. So it wants us to describe how the current, so that's on this side, varies compared to the voltage along the bottom. So what I would say is as the voltage increases, what happens to the up here, so the one going up? Well, it's increasing, isn't it? So as voltage increases, current increases. But that's only half of the story, because can you see how the line is curved and it's flattening off? The current is increasing each time, but it's increasing by less. So I'm going to say as voltage increases, current increases by less each time. Okay, so that takes us on to the next part of the question. So finally, the group connects the two components in parallel with a variable voltage power supply and an ammeter. Use the graph and an equation from page 2 to calculate the resistance of the lamp at 3.0 volts. So I'm going to do resistance equals voltage over current. So resistance at 3 volts. Now I need to come back to my sheet of paper here. So 3 volts, we run up. That's where my point is on the graph. Sorry, you can't quite see there. So I've gone up from 3 volts. And then I read across here, and that's 0.60. So I then come back. So we've got 3 volts divided by 0.6. And that's 5 on there, so that's going to be 5 ohms on the answer line here. Now, it asks us to calculate the ammeter reading. Now, if we look closely, this ammeter is serving this bulb here and this resistor here. So we already know that the current is going to be 0.6 through the resistor. We need to come back to the graph. At 3 volts, the lamp has a resistance of 0.85. Okay, so that's going to be 0.85 on there. So through the ammeter is this and that one. So that's going to be 0.85 plus 0.6. That's going to be equal to 1.45. Okay. Calculate the total resistance of the circuit at 3 volts. So that's going to be the same equation we used up here. That's going to be 3 divided by 1.45. It's going to be 2. I'm looking at this and I've got 2.6068. Now I want to do some rounding here, so that's going to round to 2.1 ohms. Okay. Right, we've got some wordy stuff for the next bit. Explain in terms of current why the whole current circuit has less resistance than the resistance of either components. Well, there's a greater flow of current through the components at the same voltage. The voltage supply is increased from 0 to 6. Explain how the graph shows that the lamp has a bigger resistance than the resistor at 6 volts. So one of the things that you need to try and remember is that on a current voltage graph, the gradient, the steepness of the line, is inversely proportional to the resistance. So the steeper the line, the lower the resistance, or the other way around, the smoother, the shallower the line, the greater the resistance. So the voltage, at 6 volts, the line for the lamp is less steep, so resistance must be higher as gradient is inversely to resistance. This is a higher tier paper. It's a higher tier question. You can see they're really testing our ability to reason on that one. Okay. Use the graph and without calculations but giving clear reasoning, compare the power of the lamps and the resistor between 0 and 6.0. So here I'm going to make use of the idea that power is equal to current times voltage. And if I look at the graph, up to 6 volts, for almost all of the time, the lamp has a higher current at the same voltage than the resistor. So I will say here, because lamp has a greater current until, now that changeover point comes at 5.5 volts. So it has a greater current until 5.5 volts. The power is higher for the lamp. Okay, and that takes you all the way to 16 marks. That's a hefty amount of the exam paper there. Some complicated skills, drawing on some deep knowledge and understanding of the electric circuits topic of work. I hope that's been helpful for you today, and feel free to check out some of my other videos. Thank you very much.